All right, let's get right into it. We're going to break down one of the most important ideas in AI today. It's a framework that's basically teaching large language models how to stop making stuff up and start relying on facts. It's called Retrieval-Augmented Generation, but everyone just calls it RAG.
So you've probably seen this, right? You ask a chatbot a question, and it gives you an answer that sounds super confident, but is completely, totally wrong. We call that a hallucination, and it's the #1 problem we're trying to solve here. So why on earth does that happen? Well, here's the best way to think about it. A normal large language model is taking a closed-book test. Everything it knows was locked in the moment its training finished. It can't go browse the web, it can't check for new info, all it can do is try to remember what was in its training data.
And that closed-book problem leads to 3 huge headaches. First, you get those factual hallucinations, where the AI just literally invents things. Second, its knowledge gets stale pretty much the instant its training is done. And finally, it knows a ton about the public internet, but it knows absolutely nothing about your company's private data or any other specialized field.
Okay, so what's the fix? Well, if the problem is a closed book test, you give the AI an open book test. And that, right there, is the beautiful, simple idea behind Retrieval-Augmented Generation. It's this really elegant solution to all those problems we just talked about.
So what RAG actually does is pretty straightforward, but it's incredibly powerful. It's a system that, before the AI even tries to answer you, goes out and finds relevant, up-to-date facts from some external knowledge source. It finds the proof first, and only then does it write the answer. You know, at its core, a RAG system really just has 2 main parts. First up is the retriever. Think of this like a brilliant, super fast librarian who can instantly pull the exact right pages from a massive library to answer your question. Then you have the generator. That's our LLM, which takes those pages from the librarian and uses them to write a perfect fact-based answer.
Okay, so let's pop the hood and see how this thing actually works. How do we get from a question to a grounded answer? It's a pretty clean 3-phase process. So here's how the workflow looks. First, there's indexing. That's all the prep work that happens offline. Second is retrieval, which happens in real time the moment you ask a question. And third, you've got generation, where the final answer actually gets put together. Let's walk through each one.
So phase 1, indexing, is all about getting ready. This is where we take all of our documents, PDFs, websites, internal company files, whatever, and we build a searchable digital library for the AI. This all happens behind the scenes, way before a user ever shows up.
Now, this indexing pipeline has 4 key steps. First, you load all the data. Then, you do something called chunking, which is just breaking big documents into smaller, meaningful pieces. Next comes the really cool part. An embedding model turns those text chunks into numbers, called vectors, that capture their actual meaning. And finally, you store all those vectors in a special vector database, which is basically a library designed for incredibly fast, meaning-based search.
And that chunking step we mentioned? It's a bigger deal than you might think. How you chop up your documents involves a really important trade-off. You can do a simple fixed-size split, which is super fast, but you might cut a sentence right in half. Or you can use a smarter approach that understands the document's structure, like its headlines, to keep related ideas together. It's a classic choice between speed and quality.
All right, that brings us to phase 2, retrieval. This is where the magic happens, and it's in real time. A user asks a question, the system immediately turns that question into a vector and searches the database for the text chunks that are the closest match. This is our librarian, in action, finding the exact right pages.
And finally, we hit the last phase, generation. The system has found the most relevant facts. Now, it's time to actually write the answer. But here's the key. It doesn't just throw those facts at the language model, it packages them up really carefully.
And this is what that package looks like. It's called an augmented prompt, and it's basically a perfectly crafted set of instructions for the AI. You've got rules for its personality, you've got the facts we just retrieved, you have the user's original question, and a final command telling it to put it all together. This is how we control the output.
Out of everything in that prompt, this one line is the most important part. By telling the model to only use the information we've given it, we put up guardrails. We're forcing it to stick to the evidence we handed it, which is what drastically reduces the chance of it making something up.
Now, RAG isn't the only game in town for customizing a language model. You've probably heard people talk about fine-tuning as well. So what's the difference, and how do you know which one to use?
Okay, the difference is actually pretty fundamental.
RAG keeps the knowledge separate from the AI. You just update your library of documents. Fine-tuning, on the other hand, actually goes in and rewires the AI model itself. So if your information changes all the time, like news or internal reports, RAG is perfect and cheap. But if you want to teach the AI a new skill or a specific personality, fine-tuning is the way to go, even though it's way more expensive.
And this field is moving so fast. People are coming up with really clever ways to make retrieval even better. One technique, called HyDE, has the AI first imagine what a perfect answer would look like, and then it searches for documents that match that imagined answer. So smart. Another trick is re-ranking, where you use a second, more powerful model just to double-check and reorder the first batch of search results to make sure they're absolutely perfect.
So after all this technical stuff, let's step back. Why does any of this actually matter? Well, because what we're talking about is a huge shift in what AI can even be.
RAG is a technology that's turning these AI models from static, know-it-all encyclopedias into dynamic reasoning engines that can actually use live external information. That is a massive leap forward. It's a total game changer.
And the advantages are just enormous. Your answers can now have citations, so you can verify them. Your knowledge base can be updated every single day without having to retrain the AI. But most importantly, it builds trust, because you get outputs that are way more reliable and grounded in fact.
And if there's one thing to take away from all this, it's this. The future of AI isn't just about building bigger and bigger models. It's about building smarter systems that know how to find and use the exact right piece of knowledge at the exact right time. That's the real genius here. Which really just leaves us with one last question to think about. From science to business to our everyday creative work, what really becomes possible when our AI tools never have to guess again?